So in this video, we are starting chapter 1. We're looking at section 5.1 first. If you haven't done so already, if you don't have a copy of it, why don't you pause the video and go to Canvas, and under the Files tab, you will see Unit Conversions. That's a paper that has conversions that you will need not just for this section, but for the entire chapter. So print that out for yourself, and it'll be very helpful when you're doing the next couple sections. With 5.1, we're starting off with looking at the U.S. measurements, and a lot of these might be familiar to you because you use them often, but some of them might be less familiar, such as the pints, quarts, gallons that you may not use all the time. When we're looking at changing from one unit to another, we're either going to go from a larger unit to a smaller unit or smaller to larger. When we're converting to a smaller unit, we have to multiply because it takes more of the smaller units to make a larger unit. So for example, if we're converting from quarters to pennies, we would have more pennies, quantity-wise, 25 of them, than 1/4 because we're converting to a smaller unit. And when we're converting to a larger unit, we have to divide to get that answer because there are fewer larger units. So we could exchange 10 dimes into $1 because dollar is a larger unit. We only have one of those dollars where we had 10 coins for our 10 dimes. If you're not sure which one's larger, which one's smaller, again, maybe like the quarts and pints and things like that, you could also use a unit fraction to ensure that you're doing division when you need to divide or multiplication when you need to multiply. And the way you would do that is use a unit fraction. Unit fraction, unit means 1. You're creating a fraction where the top and the bottom are the same amounts, so therefore the fraction is equal to 1 because anything divided by itself is 1. However, you're writing it in equal amounts with different quantities, and it might not come out right, but for example, if you're given ounces and you want to turn it into cups, the numerator should be the units that you need to keep, the desired result. So in this case, it would be cups because we want our answer to be in cups. The denominator should be in the original unit of the measure, the one we're getting rid of, we're changing out. And so, again, if it was ounces to cups, we're trying to get rid of ounces and keeping cups. So ounces would be in the bottom of that. And we'll look at an example of both of these to help us with that. So for our first example, we're going to figure out how many seconds are there in a 5-day work week, assuming an 8-hour day. And so we don't really need to set up a unit fraction for us to figure out how many hours are there in a 5-hour or a 5-day work week when we're working with 8 hours per day. We know that we just need to multiply 8 times 5, not divide, to get 40 hours worked that week. And again, this is an easy one for us because we're dealing with time, which time is something that we work with every day. And so let's just show using a unit fraction how we would do that. We want to get from hours all the way to seconds. So we're actually going to need to use more than one unit fraction in order to get there. So if we take our 40 hours, we need to get rid of hours. So our unit fraction would have hours on the bottom. And I don't know how many seconds are in an hour right off the top of my head, but I know how many minutes are in an hour. So I'm going to start there. And so the equivalent would be 1 hour is 60 minutes. If we wanted to write our 40 hours over a fraction, we can just put it over 1 because we know anything over 1 stays the same. But notice how our hours from the top can cancel with our hours on the bottom. And we're multiplying across, so 40 times 60 will give us the amount of minutes. But we weren't asked for minutes, we were asked for seconds. So we're going to have to add another unit multiplier. And right now we're in minutes. So we want to get rid of minutes. And we're going to keep seconds. So minutes went on the bottom, so I can cancel minutes with minutes. And finally, I have the seconds, what my answer requires. And then I can put in, again, that 1 minute is equal to 60 seconds. So now that we've done that, we can see that we're taking our 40, which we got by 5 days a week times 8 hours per day, and we're going to multiply that by 60 and then by 60 again. If we were dividing, a number other than 1 would be in the denominator. And when we do that, we get that there are 144,000 seconds in that 40-hour work week. So after work on Friday, you can say, whew, what a long week it's been. I worked 144,000 seconds this week. Sounds impressive, doesn't it? So here's one for you to try. You're going from ounces now to gallons. And so again, the charts, the measurements that you printed off or received in class is very helpful if you're not sure of the different conversions between getting from ounces all the way to gallons. So pause the video and try it out, and then resume the video and check your work. I'll go ahead and use those unit fractions just to make sure that I remember and you can see whether we're multiplying the numbers that we're using or dividing them. Okay, notice how many unit conversions I needed to get from gallons to ounces. There was 4 quarts to get rid of 1 gallon, 2 pints to get rid of 1 quart, 2 cups to get rid of 1 pint, and then 8 ounces to get rid of 1 cup. So we multiply all of those top numbers together, and we get that it's 1,024 ounces in 8 gallons, more specifically fluid ounces, because there are weight ounces as well. It's 16 ounces in 1 pound, but 8 fluid ounces in 1 cup. So let's look at some of these true or false ones. You might not know all the answers to them, but we'll go over them together. So capacity can be measured using ounces, quarts, and gallons. Capacity is the amount of space inside of something to fill something up. So capacity is another word for volume. And so yes, ounces, quarts, and gallons are those units in the US measurement. So that is true. For question 2, it says that there's 2,000 feet in 1 mile. That one's false, and it is 5,280. And if you're like me, you are probably wondering, am I going to have to remember all of these? And the answer is no. The same charts that you have printed out for yourself, you'll be given one on any quiz or test that you need. You don't have to print it out and bring it to class yourself. We'll make sure that you get a blank copy of it to use for quizzes and tests. So to convert from smaller units to larger units, division would be required. So again, if I'm not sure, I give myself a scenario to think about. So again, money is easy one. If I'm going from smaller units, such as pennies, to larger units, let's say dimes, I'm going to have a larger amount of pennies and dimes. And so to make it smaller, I would divide. So that is true. Multiplication by a unit fraction does not change the value of the expressions being converted. Well, again, unit fraction means a fraction equal to 1, and anything times 1 stays the same. So it's helping us to convert units of measurements, but it doesn't actually change the value. So that is true as well. Okay, so here's practice for you on converting pints to cups, miles to feet, feet to yards, and minutes to hours. And here's just a couple of those pieces of information from the charts from the paper for you to look at while you're working on them. And so again, pause the video while you figure those out. And then when you're ready, check your answers. Okay, there they are. If you made a mistake, you probably multiplied when you should have divided or vice versa. And that's why I like those unit fractions so much, because it takes the guesswork out of it if I'm not sure whether I'm supposed to go bigger or smaller. So let's look at a couple of applications now. Sheer fabric costs $7.99 per yard. If it will take 35 feet of fabric to make drapes for the entire house, how much must you spend on fabric for the drapes to the nearest cents? So we're given our cost per yard, but our measurement per feet. And so let's take the 35 feet that we're given and change it into yards, which is for our cost. So again, the yard is the unit of measurement we want to keep, so that goes on the top. Feet is the unit of measurement we want to get rid of, so that goes on the bottom. And the equivalent ratio is that there's 3 feet in 1 yard. So that'll convert that into yards. But then we have to pay for it, so it's going to be multiplied by $7.99 per yard. Remember, per is another way of writing a fraction. Yard means 1 yard, so that's our unit rate, unit cost. And so when we do that, notice not only do our feet measurements count, but yards cancel out, and so all we're left with is dollars. And so it'll give us the price. So we can do 35 divided by 3, since 3 is on the bottom, times $7.99, or you can go ahead and multiply straight across and do the 35 times $7.99 and then divide by 3. Either way you work that through, you should get 93.216 repeating in the calculator, which rounds to $93.22. Not bad price for the entire house for curtains. The author of this textbook spent 1 year, 23 weeks, 5 days, and 14 hours writing it. How many seconds is this? Whew. There is 52 weeks in a year is what we're supposed to use to start. So now we have to convert and keep converting and adding to keep going down the list. So let's change our 1 year into what they tell us that we have 52 weeks. And then let's add the 23 weeks onto that. And so when we add those together, we get 75 weeks so far. Now we have to add days to that. So there are 7 days per 1 week. So I'm getting rid of weeks and keeping days. So we have to do 75 times 7, which is 525 days. But now we have to add 5 days more to that from our list. So now we're up to 530 days. And so now we have to go from days to hours. So we have 530 days times 24 hours per day. And so that gets us down to hours with an answer of 12,720. And then we add our 14 hours to that, and we've used up all the amounts of time that they've given us. So that is 13,734 hours. And so now that I've done with my big laundry list, I am going to say that we have 13,734 hours. And we've done hours to seconds already as an example. It was 60 minutes per hour and 60 seconds per minute. So I'm not writing those labels just because I'm starting to get to where my numbers are too large for my width of my screen. So that goes from hours to minutes and minutes to seconds. And that big long number is 45,842,400 seconds. It's a lot of time. So now there's a couple thought-provoking questions. Colby needs to find out how many yards are in 1 mile. What 2 sets of equivalent units would you need to make that determination? Would he need? Because if we look at our chart, there's nothing that goes from yards to miles. So what would Colby do to be able to get that? Pause the video and jot down your thoughts, and then you can compare your answer with mine. So when we look at our chart, we can see that we have miles to feet and feet to yards. So he would need to know that there's 3 feet in 1 yard and 5,280 feet in a mile. And so I wrote out the conversion for that we have 1 mile is equal to 5,280 feet. So that gave us feet and got rid of miles. And then there is 3 feet to a yard. So we would have to take that 5,280 feet divided by 3 to get the answer in yards. And the last question, in your own words, explain when you would multiply and when you would divide when converting between units. So again, pause, give yourself some time to think and write, and then when you're ready, continue. So again, when we are dividing, we're converting from smaller units to larger units. And when we're multiplying, we're converting larger to smaller. And to ensure you're doing the right thing, using those unit fractions when necessary helps eliminate the guesswork if you're not sure. Other than that, I will let you go so you can work on your questions for section 5.1 in Hawks. If you need any help, don't forget to screenshot it and send it to me, or get help with the tutoring center or wherever you need to be able to get that lesson completed and move on. I'll see you next time.